So we're going to practice node affinity on Kubernetes. Great things don't come from comfort zone. Never come from comfort zones. We're using the Kodekloud.com platform, which is a platform to practice DevOps skills. So how many levels exist on node 1? First of all, how many nodes do we have? We have node 1. How many levels do we have there? We can see it in two ways. First, we can look at the description of the node, and somewhere at the top we are going to see the levels. So we have, this is levels here. We have 1, 2, 3, 4, 5. The second way is to look at the definition file, and we can actually do that by looking at the pod, the node, and displaying the output in YAML format. It has like the definition file of how the node was created, so we can see levels here: 1, 2, 3, 4, 5. First answer. Okay, what is the key? Not key. What is the value set to the label key? Now this, for this particular key, what is the value? That's what we're being asked. So we have hash, this one, beta.kubernetes.io/hash. so the value is emd64 here. Okay, apply a label to the node file. So we need to add the sith label. I'm going to recall this command, and I'm going to redirect it to a file. Let me just call it node01.yaml, just to have the description file somewhere. And then I'm going to delete the node. So if I list nodes, normally I shouldn't see anything. I shouldn't see node 1. Okay, so now I'm going to edit the node 1 description file, and then we're going to add another label. With the color of blue. Color blue. We're using VI to edit, so colon W to save and Q to exit, and then we're going to apply modifications, CTL. I'm going to apply that file, and then if we list our nodes, we should have our nodes, and then we can check if using the description if our new label is added. Let's describe the node, this, and somewhere up we have color blue. So if we check, we should be okay. Create a new deployment, name blue. kubectl, create, we can say deployment, and we can use the short form deploy, and we'll give the name blue, and we give the image equal to nginx with 3 replicas, so we can give the number of replicas to 3. Enter. It's created. So if we do just to make sure everything is okay, so if we list the deployments, we can just say deploy all deployments. We have one deployment called blue with 3 pods, because we had 3 replicas. So if we check, we are okay. Now, which node can the pod for blue deploy be placed on? On which node can this pod, not this ports with 3 because there are 3 replicas. So just to make sure we have our 3 replicas. You see all of them have a blue appended to the name because they all come from the same deployment. So on which node can these ports be placed on? I don't know why that question, but I think since we are doing node affinity, let's get nodes. Since we are doing node affinity chapter, it has to do with if it has affinities for a particular node or if it has taints and toleration. For now, we're going to check. We have 2 nodes. We're going to check if there are taints on any of them. So we're going to describe the control plane node, and we're going to check if it has, using the grep keyword, we're going to check if it has any taints. It has no taints. We'll do the same thing for node 01. None of them have taints. So I guess it can, the nodes can be placed on either control plane or node 1, but in reality we can check on which node they're eventually even placed. So if I describe the port, there are 3 ports. Let me take the first one. If I describe this port and then I grab through the description and see on which node it is on the control plane. Let's do the same thing for the second port, this one. This time around it's on node 1, so it can be placed, no need to check the third one, so it can be placed on control plane or on node 1. Now set node affinity to the deployment to place the ports on node 1 only. So right now the ports can be placed on any of our 2 nodes. So we're going to make sure that they can only go on node 1. For that we need to use node affinity, for which I'm going to go to the documentation to look at the syntax. I'll just look for affinity, something like that. The principle is simple. Normally you need to have the label on the node first. Remember we just set color blue, so we just did that already. Let's confirm that it's still there. So if we do describe node 1, nodes with an S, zero 1. I actually just typed the letter O, not 0. That's why I have having errors. So we have our labels color blue. We are going to use that because we just created that unique. So we have 2 nodes, and this one has been given a label. So we're going to make use of that label and make sure that all our ports can only be scheduled inside this node by giving them an affinity to this node. So let's go back to the doc and look for the affinity syntax here. I should find it somewhere, something like this. Okay, I'm going to copy this one, affinity, and let's go back to our deployment. So now we need to modify our deployment actually. kubectl, because we don't need to modify the 3 nodes because all of the 3 ports, because all of them come from the deployment. So if we modify the deployment, we are going to have 3 new node ports created. Sorry, ports, not nodes. So let's get deployments. We have 1, so we need to edit that. We need to return the output in a YAML format, and I'll just call it the blue deploy.yaml, and I'm going to edit that file. And at the spec section here, beside at the same hierarchical level as containers, I'm going to add affinity section. I need to do a copy paste from here. Whoa. So we need to make some indentation. So under affinity we have node affinity, and then under node affinity we have this very long keyword, and then under that we have this array, and let's see, preferences on the same level as this. We just need to maintain the same hierarchy, if not we're going to have a syntax error for YAML files. So under preference we have match. Normally when you see the colon followed by nothing, it means everything that comes after it's a child. So the same thing for matching expression. So we have key under match expression. So key is actually an array. We have operate, we have values, and then we have, oops, no need to check, value is SSD is under values. So we are not done. We are actually changing the deployment so that they have an affinity for the blue node. So we want it to be obligatory, so we're going to use preferred. We're actually going to put there 2 keywords. There's preferred and I think there's required. Let's just check somewhere and the documentation that's required. So because preferred means we'll prefer the node, but if we don't find anything, the scheduler can do what he wants, right? We're going to actually require that action required. The weight, I don't know if we need to use the weight. I don't think so. I don't know why there's a weight there. Okay, I think I copied something wrong. Okay, I'm going to, I don't know why there's a weight there. There wasn't supposed to be a weight, so I actually badly copied the text. So I'm going to quit and we'll do that copy. I'm going to quit without saving, and I will open the blue file. Okay, and let's come back to the spec section. So since we're using a browser, I'm going to do something that's simple. I'm going to copy all of this. Oops, I can't scroll. Crazy. All right, let's forget about that. So I'm going to create a new section called affinity. It's easy. Let me just copy and put by the corner so that I can do copy paste. So we have the affinity section here. Copy and put it under the same level as containers, just like here. So at the same level as DNS policy. Paste. Right, so this is what we have. We have affinity. Under we have required. Under that we have the node selectors. And under matching expression, we have the key, then we have the operator, and we have the values. And under values, we have another array. All right, so we are back to our updated file. So in order for this deployment to be scheduled on node 1, we needed to match the label on node 1. And what is the label? We have something like the color label should be in the values blue. I think we have color and blue. This is it here. Required during scheduling, not during execution. We have it here. Node selector item, the color, the key is color. We have it here. The value is blue. I think I need to indent again properly that blue. And then we save this. So I can actually delete that deployment and we'll create a new one from the blueprint. So I'm going to delete the deployment blue and create a new one by applying the changes in that file. We have an error on line 40, so we need to check for that. I'm going to set line numbers and let's look for 940. Yes, because affinity is not on the same level as containers actually. So we have formatting issues here. This is very peculiar with YAML files, so I need to be very careful. We shift everything by 1. And then we save and then we reapply and everything is good. Let's check. We are fine. And then which node are the port placed? So we need to actually check if they have been placed on the node 1 port. So let's get our nodes, our ports. So we have 3 of them, and we're going to check on which node they are placed. A simple way to do that is to describe the port and pipe. Let's give the port names and pipe it and grab on which node they are placed. Node 1, we can do the same for the second one, which is CCN6 here, from here. CCNN6, right. It's placed on node 1, so let's check the third one, which is R2, it's 86L. R2 86L. So our 3 ports are placed on node 1. Yeah. Now create a new deployment called red. So let's create a new deployment. Deploy for short form, we'll call it red, with an image nginx with 2 replicas. And ensure it gets placed on the control plane, which means we need to change the affinity and make it compatible with the control plane. I guess the control plane has many labels, but we're being authorized to use this particular label here. Okay, so we are not going to create that deployment now. We're going to put it in a dry run. We're going to put it in configuration file in a YAML output format and redirect that into a red.yaml and edit that file so that we can add our affinity. So under the container section, I'm going to make every pod under that container, every pod under that deployment to be compatible with the control plane. So let's go back to the documentation and look for the, I just open Kubernetes here. I'm looking for the affinity description keywords. From here, I'm looking for something like this. So I'll copy these values again and go back to our exercise and add it here. And make sure they were indented again. Like this. Up. I actually add 2 spaces for the indentation. And now this key is under match, operator and key the same level, values and operator the same level, and this is actually under values. So we need to make it compatible with the control plane. So in the control plane we have this label called node role control plane. So I'll copy that and we'll put that label under the key. Normally for the first affinity that we did using the 3 replica deployment, we actually did a label, key and value pair, but here we are just giving label, we don't have any value. So we can actually use another operator called exist, if I remember very well. Let's check the documentation. I can't find anything here, so let's go to Google. Exist node affinity Kubernetes. Exist operator. That's it. So let's come back to the tutorial. It actually exists. So exist actually exists. So we're going to look for exist here. And I think we don't need the values. Let's just test that and see. So we're actually making sure that every pod under this deployment has a node affinity if this label exists somewhere. That's all. We don't need to give a value. So I'm going to save and let's cross our fingers and deploy and apply that and test. -F, right? The deploy red is invalid. Node affinity invalid exists. We need to check that again. It's actually wrong. So let's look at other Google files. Let's look at this one. Soft affinity. In node affinity conflict. Okay, I'm looking for something that checks if the label is existing. So this one checks if the label type is there with this value. The same thing here. So if this label exists and the value for that label is app worker node, the same thing here. This is like the standard way in every block that we are searching for. The same thing here. So we can also just Google and see the number of operators that exist in node affinity. List of all operators node affinity Kubernetes. Let's do some research. Okay. Let's check this one. Not in. So we have the not in to show that we have a label that is not. This is the in. This is the exist. There's actually exist, but with the capital E. So that's what I was looking for. So let's modify the red. And let's modify this. So it's going to deploy this pod on any node that has this label in existence. We don't need to check the value. So we save and let's retry the deployment. Seriously, we still have an error. So it says invalid via exists, not a valid separate selector operator. Is it actually deleted or what? This is operator exists. I can see that in the doc. Match expression size exists. Let's go back to that file and see something. Operator exists. Okay. Right, since that is not working, let's go and check actually all the labels that exist on the control plane node. So let's describe the node control plane like this. And where is our label? This is our label. Node role Kubernetes IO / control plane. This one, and it actually has no value. This is actually empty. So let's do something. I'm going to re-edit that file. And since that, instead of using exist, since it's causing problems, let's say in values, and I'm going to put an empty string. And let's see how that works. Okay, let me apply the red, and then let's check. It actually works. It's just that the exercise recommends that we use the right operator. I don't know why. Okay, I'm going to stop here. I don't know why. But if I check, I'm going to add a comment under the video if I see the solution other than this. But this is another way to do that. Since it has an empty label, we can just use an empty string. So see you on another video for another exercise.